What if I told you network admins are wasting hours on configs that could be automated in seconds? SDN is revolutionizing networking, but is it really coming for your job? In this video, I'll expose the shocking truth about software-defined networking and show you how it's changing everything from VLAN setups to firewall rules. The future of networking is here. Are you ready? SDN, Software-Defined Networking. SDN is the latest buzzword in IT, which is becoming more and more popular every year. Some network administrators have read or heard some rumors that in the future the entire network will be programmed, and now fear that their jobs will be replaced by programmers who know the languages inside out: C, C++, Java, or Python. So, what is SDN, and why is it becoming so popular? Are network admins right to be concerned? To answer these questions, we will first examine in the first part of the course the traditional network and its limits. Then, in the second part, we will see what SDN is and how it is supposed to solve the limits of the traditional network. The network has always been very traditional. We have specific network devices, such as routers, switches, or firewalls that are used for specific tasks. These network equipment are sold by network vendors like Cisco and often use proprietary hardware. We configure them mainly via the command line interface, CLI, rather than through the graphical user interfaces, GUIs, such as CCP, Cisco Configuration Protocol, for routers, or Adaptive Security Device Manager, ASDM, for Cisco ASA firewalls. We will now detail the different functions that a router must perform in order to be able to transmit an IP packet. It must check the destination IP address in the routing table in order to know where to forward the IP packet. Routing protocols such as OSPF, EIGRP, or BGP are required to learn the networks and the networks installed in the routing table. It must use ARP to find the destination MAC address of the next hop, or destination, and change it in the Ethernet frame. The TTL, time to live, which is the lifetime of an IP packet, must be decreased by 1, and the checksum of the IP header must be recalculated. The checksum of the Ethernet frame also needs to be recalculated. The checksum can be seen as the imprint of the IP packet, making it possible to verify that it has not been modified on the road. This word literally translates to checksum. All these different tasks, which we have just seen, are separated by different plans. In all, there are 3 of them. We have the control plane, the data plane, and the management plane. We will now detail all of these 3 plans. The control plane is responsible for exchanging routing information, constructing the ARP table, and so on. Here are some of the tasks performed by the control plane. It will learn the MAC addresses to build a table. It will run the spanning tree to create a loop-free topology. It will create the ARP table. And it is the one that will execute the routing protocols like OSPF, EIGRP, and BGP by creating the routing table. The data plane is responsible for the transmission of traffic. It is based on the information provided by the control plan. Here are some of the tasks that the data plane supports. It is the one that encapsulates and unencapsulates the packages. It adds or removes headers, such as the 802.1q header for VLANs. It will match the MAC addresses for the transfer. Match IP destinations in the route table. Change the source and destination addresses when there is NAT, network address translation. And it will remove traffic based on ACL's access control list. The management plan is used to access and management of network devices. For example, connections via Telnet, SSH, or the console port. When talking about SDN, software-defined networking, we must keep in mind that the control and data plane are the most important. To help you visualize the different plans, here is an illustration of the control and data plane. On the diagram, we can see the control plane where there are routing protocols like OSPF, EIGRP, and even some static routings. The best routes are installed in the routing table. The router must also build the ARP table. The information from the routing table and the ARP table is then used to create the forwarding table. In this way, when the router receives an IP packet, he will be able to transmit it quickly because the transfer table has already been built. The limits of the traditional network. All we've just touched on is how networks have worked for decades. So, there is nothing wrong with traditional networks. But nowadays, some businesses challenge themselves on different solutions. Let's take this topology as an example. In this diagram, we see a network infrastructure of a company's data center. At the very bottom of the topology is a VMware ESXi server with a number of virtual machines. This server is connected to some switches in the access and aggregation layers. There are also 2 ASA firewalls for server protection and 2 routers for access to the outside world. And at the very top, we have a router with a user, PCA. Now, suppose this company wants to acquire a new application that would require the installation of 4 new virtual machines on the VMware server. So, for security reasons, each VM will need to be in a different VLAN. PCA, which is behind router 1, must be able to access the application that will be on these virtual machines. We will see some steps which the network admin will have to configure for this need. It will have to create all the VLANs on all the switches. You will also need to configure the route bridge for the new VLANs. It will have to assign 4 new subnets, 1 for each VLAN. New sub-interfaces with IP addresses on the switches will have to be created. Configure redundancy for new VLANs with either VRRP or HSRP. Configure the firewalls so that you can access the application and the various subnets. And new subnets will also have to be advertised in a routing protocol on switches, routers, and firewalls. So, while there are network automation tools to make it easier for us, in general, the network admin will instead use the CLI to configure all of these devices, one by one. It is therefore a very slow and manual process that a natural person has to do. While it only takes a few minutes for the system team to run a new virtual machine, it can take a few hours for the network team to prepare the topology equipment. In addition, these types of modifications are usually made outside of production, that is, outside the company's business hours. Server virtualization is one of the reasons why businesses are looking for something that speeds up the process of all the tasks we've just seen. Before virtualization, we had a physical server with a single operating system. Today, we have multiple physical servers with hundreds of virtual machines. And these virtual machines can automatically move from one physical server to another. When they cross the layer 3 boundary, it would be ideal not to have to wait for the network team to make the necessary changes to the routing or ACLs. It should be automatic. And since the trend these days is that everything has to be virtual, it's not surprising to see that this happens in networks as well. Large companies such as Cisco that used to sell only proprietary hardware now also offer virtual routers, ASAs, wireless LAN controllers, which can be run on VMware servers.